Hello and welcome to the lecture on surface area to volume ratio. Today we're looking at surface area to volume, and typically for cells these are spherical structures more or less, and so in this drawing here you can see the surface area is the area on the outside and the volume is the stuff on the inside, right? Now the equation for surface area for a sphere is 4 pi r squared, r being the radius, right, from the middle to the edge. And the formula for the volume is cubed, so 4/3 pi r cubed. So we're noticing is the difference in the exponent here. And that means that as you get larger spheres or larger cells, it means that the surface area increases by a square function and the volume increases by a cubic function, which is 2 to the 2 and this is to the 3. So you're going to see the surface area always increases less, and this one increases more. So as a result, the ratio gets smaller as the cell gets bigger. So the entire ratio gets smaller, right? So you get less surface area per volume as spheres get larger, or cells, however you want to think about it. All right, so the simple example that I have here is a nice drawing. Now this doesn't work with spheres, but it does work with cubes, which is a little easier for doing the math. This cube right here is 4 centimeters on a side, right? That's 4 centimeters there. So it means it's 4 centimeters here. So this single cube, for example, this big large cube has a surface area of, it has 6 sides. This is side 1, 2, 3, and there's 6 altogether. And each of those sides has an area of 16, right? So the surface area is equal to 6 times 16, which is 36. 6 and 1 is 6. 96, okay? Carry the 3 there. I forgot to carry the 3. That's a 96 for the surface area. All right, and the volume of this cube is going to be equal to 4 times 4 times 4. So we go length times width times depth over here. So that is 4 to the 3rd, which equals 4 times 4 times 4, which equals 64. So the volume, surface area to volume, we actually have more. So this is our surface area to volume ratio. Now what you're going to see, there's a lot of surface area. Whoa, yeah, well that's how it is. Let's go see what happens in the next case. I'm going to go ahead and skip all the way to the final case and let you guys solve the middle one. In this case, we have little tiny cubes. So each of these cubes has a length of 1 and a height of 1 and a depth of 1, right? So this is 1, 1, 1, 1. Now, if you want to count how many cubes there are total for the volume is exactly the same, right? Because it's the same size, 4 by 4 by 4. So the volume in this case hasn't changed at all, but we have a volume of 64. But now we have a bunch of little cubes in here, so each of those little cubes has a larger surface area because of all the surfaces that are inside the cube now that are now exposed. So if we want to count all of those surfaces, each cube has a surface area of 6, right? So that's going to be, each cube is going to have a surface area of 6. We're going to have to multiply that times the number of cubes, which is, well, you can see 16 on one layer here, and then there are 4 of those, 1, 2, 3 more, which makes 4. So 4 times 16 is 64, so 6 times 64. I'll put it like this so I can do the math. 6 times 4 is 24, 2, 6 2 is 36, 37, 38. 384 over 64. So you can see now that when the little cubes are here, there's a much greater surface area for the same amount of volume. You could also look at this in a way of saying that the surface area to volume ratio, here there's relatively little surface area, and here there's a lot, right? That's holding volume constant. This becomes important in a cell, because if a cell is very small, it has a lot of surface area relative to the volume. So if you need stuff to come in from the outside, you can easily get stuff to come in. Maybe you're trying to bring in sodium, right? It's easy to get some in to the middle. But when your cell gets really large like this, you have little surface area relative to volume. So it's hard to get enough sodium in to make a difference to this huge volume in the middle. For this reason, prokaryotic cells tend to be very small, and eukaryotic cells are able to get larger because they are subdivided inside and they have organelles that help them move things from the outside to the inside without having as much high surface area to volume ratio.